Hello, my name is Dylan Palmer, and this is my presentation on cyber-physical system security. What are cyber-physical systems? Cyber-physical systems are multi-component distributed systems that function independently of human operators and control crucial aspects of life. Now, what does this mean? They are interwoven pieces of physical and digital media, digital systems that cannot be disconnected. Examples of this are some medical devices, cars, smart grids, smart farms, um, any device in which there is a lot of information that is being traveled through the internet, and that it is changing something physically through its processes when it is working. Here is an example of a cybergrid or a smart grid. Uh, as you can see on the left here, there's different ways of generating power. It is being transmitted. The infrastructure is being distributed through some sort of um, the energy grid itself. Um, those controls of how it's being distributed are being controlled through the transmission lines, um, through some sort of central service, um, and those distributions are then it's being distributed to everywhere that needs power, which is anything at this point, through factories, homes, and vehicles. Um, Anytime there is for a cybergrid, there is going to be sensors um, all along, as well as other points of entry that feed data to this central figure uh, to let them know what's going on, both for who needs power, uh, when there is specific changes that need to be done to help them figure out what's going on. Here is an example of a smart car um, or a normal car. For your key uh, has a remote starter in it, probably, that sends a signal to your car to start it or even open the trunk. Um, your car then has onboard sensors to not only feed data to your phone uh, and the internet, but also to feed some of that information uh, back to the dashboard to let you know if there's something wrong with your engine or your brakes or the battery. There's also the GPS that is connected to your car so that you can find out where you're going, and the radio so you can listen to some tunes if you don't connect it to your phone, and Bluetooth so you can connect your phone. Now there are various problems with cyber physical systems as they are very complicated. There's more vectors of attack. There's more ways for people to get into these systems. Um, and because there are more devices on the internet, they need more bandwidth to get to practice to use on the internet themselves to actually function. They're also they're often very um, sensitive to time delays. If there's something wrong in your engine and you don't find about it fast, you can crash your car or something worse can happen. If the energy grid doesn't find out about some spike in power, then there can be blackouts. Here are different types of attacks. Um, I'm only going to focus on a few of them. There's more that I did not focus on. Denials of service are one of the biggest threats to CPSs, and also a big threat to um, normal servers as well. They tie up uh, resources and services that a normal user would like, that we use, and uh, can either maliciously or to uh, for some uh, for another purpose on top of that. As cyber physical systems have more entry points, there are more targets for DOS attacks. Um, such as the smart meters in a smart grid, which uh, once they are targeted with a DOS attack, can't be reset as they are not as they are sensors and not uh, they can't be reset because you can't get a signal out to them. Malware injection is also a very common tactic for a lot of CPSs. Um, Instead of going for the loud DOS attack, it is something that you try to remain undetected. It can either be it introduces false information into the feed either once or multiple times, like the peer pricing attack, uh, which repeatedly puts information into the about prices uh, into the smart grid over a long period of time, and which can lead to overgeneration of power or large loss of profit for this smart grid. There's also the automatic generation control attack. And AGS itself um, is a system that helps control large areas of power to help load balance. So if you mess with that, you can mess with how much power is being sent to different zones or different areas to there are a couple different ways to do this. Either scaling a ramp, pulse, or random attacks. For example, a ramp attack would gradually increase or decrease the measurements in the AGC over time. Someone who might want to do this would be a rival energy company who would slowly decrease the measurements of this smart grid so that they could then ramp up their output and get more money. Here is an example of potential attack vectors. As you can see, that there's the controller off to the left and the networks that are being attacked at the cyber layer, and a potential attack at the physical layer. Here are some of the effects that can happen from these cyber physical attacks. A lot of damage that can be caused. You can heat up the sensors in a barn, kill off livestock. You could tie up all of the transmission data in a smart grid to make it so they can't find out about any changes that are going on in energy needs or in their system itself. There are a lot of things, both specific and broad, you can do. And a lot of these hacks end up having very physical damage that gets caused by them. Here's a closer look at some of the attacks by the internet layers. You can see the denial of service attacks is on the application layer, and the malware injection is at the computing layer, and some of these other attacks at different layers as well. Here is an example of a smart farm with its different layers. They are relatively new in what they are in the field of cyber physical security, cyber physical systems, but there is a lot of potential for what these internet-enabled devices can help them with, from the sensors that feed data directly to the cloud layer, for the farmer to understand exactly what all the conditions are, to being able to log on to use their phone or their computer to directly sense see the feed of their own or potential their own data for their cattle, see if there's anything wrong, or for the sensor data for any cattle that they might want to buy to see if they're also healthy. There's a lot of potential there, but there's also some problems that need to be ironed out as well. At the physical layer, as mentioned, there is a lot of sensors that exist that are mostly low power, from the soil sensors to sensors in livestock to greenhouse sensors. But there's also things like tractors to drones, all of the things that connect directly with the physical, that affect the real world. That is what is the physical layer. Then there is the edge layer. Well, this is the first computing layer, so there's a lot of stuff that's coming from the cloud down into here, such as the AI system that is trained on the cloud and then deployed on the edge layer. Then there's also things like the security monitoring, or even any sort of detection that is set up is also run on the edge layer. But as there's also increased security risk, due to the extra access points that go through the edge layer. Then there's the cloud layer. There is some software that they might get from John Deere or whatever company that they buy their equipment from, as well as whatever software data that they use to run their farm, as well as whatever data there is being collected from their sensors themselves. That is being pushed in from the edge layer. But as mentioned before, the cloud layer is becoming increasingly the target of attacks because if you control a cloud, then you can do much larger, grander scales of denial of service attacks using these scaling virtual machines. And then there's the network layer. It mostly includes the Internet of Things, which is all of the previously unconnected devices, the sensors, the drones, the equipment. Now that they are able to connect to the internet, that is what this Internet of Things is. And then, of course, there's also the other subnetworks as well. Your Wi-Fi, your radio frequency, even your Zigbee. All of that connects here, and this network layer doesn't just have those that exist here, but they all interconnect and this layer tries to maintain all of them and make sure that they are all running as concurrently and that none of them interfere with each other. The biggest problem specific to smart farming is that a lot of the Internet of Things specifically, because there are a lot of sensors, that they are low powered, and that these low powered devices are too low powered for authenticating using public key encryption. So they need other forms of encryption that is fast and easy to implement, but also safe for when they join the network, so that it is hard to hijack the smart farm through all of these various Internet of Things devices. And then also there is the problem that there is a lot of workers on the farm. However, a lot of them only work during a peak season and not all the time. So there's the need for temporary access to these smart farm services without that the access being too much or interfering with the core users without being too high of authority. I've talked a lot about what these systems are and some of their problems. So now I'm going to go over a little bit about what might be done. Here are his a defense strategy, a few notes for anyone who has a cyber system security, cyber physical system. to look over its security, so that they don't have to hire a specialist to. Here are some keys to defending, uh, uh, actually shoring up your defenses after you've looked at your after you've looked over your system yourself. Um, Protecting and verifying key measurements. Um, if you are able to uh, lock in some measurements, or find a way to double check them in the system. Um, However, double checking too many creates a large amount of overhead, so that is a problem. Using statistical models, um, there are various models that were more complicated than I wanted to get into, that help with very specific attacks, um, that will help to um, narrow the possibility of uh, a system being hacked by certain attacks. Um, Using supervised learning models, um, machine learning there's been more and more research into using machine learning for cybersecurity in general. Um, so this is one of those methods in which they have found some validity in using it. And then also finding better ways of protecting your Internet of Things, as that is one of the weak points in security. Here are some of the ways in which your Internet of Things can be protected better. Um, Trust management. Um, there are various ways to better protect your trust. Um, Encryption, better key exchanges. Um, of course, there are power requirements to all these, so there's trade-offs for something like that. Using a better routing protocol. So making sure that your routing protocol um, is not too basic will make sure that there is more security, or at least that is harder to guess which one's where. This one is less a security thing and more just one that exists, as mentioned on the network layer. There are multiple layers, wireless channels that have their own security protocols, and that's just they're all going to exist on the same level as the Internet of Things. Lastly is privacy protection. A internet, a node can request privacy when entering a network, which will help increase its anonymity and be less likely to be found when a bad actor is looking for it in the network. Here are my sources. Thank you for listening, and have a good day.